Hi all. Today I am going to explain about the operators in Python. I have explained the operators in C in my previous video. Basically, here we are doing an example, we are taking an example of addition. We have two numbers 15 and 27. The plus symbol is called as the operator and 15 and 27 are called as the operands. So to do a function or an operation between two operands, we need an operator and that symbol is called as the operator. Let us see what are the different types of operators we have in Python. These are the different types of operators in Python: arithmetic, assignment, comparison, logical, bitwise, identity operators, and membership operators. Let us check one by one. First is arithmetic operation. We know we have addition, subtraction, multiplication, division. So the plus symbol is meant for addition symbol, addition operator. And if I have an variable x as 300 and y as 17, and if I assign z equal to x plus y, and if I print, obviously it's 317. That's what I get. Same way for subtraction, if I have these two numbers and instead of that plus symbol, I replace that minus symbol, nothing but the operator is changed, then I get the answer as z equal to 283. If I multiply these two, then I'll get the answer as 510. So I'm replacing the plus symbol by the asterisk. Same way, I'm replacing the plus symbol by the slash. So it is actually meant for division operator. So I'm dividing 300 by 17 and I get this answer. And this is the uh, modulus symbol, and here we'll get the remainder of the operation. If I do x by 7 y, then I'll get the remainder of that particular operation, so I get it as 11. And this is the power exponent. I put it as x power y, which means 300 power 17. So the answer is z equal to this. Though we have these many operators here, we need to know what are the hierarchy of arithmetic operators or the precedence, the way which has the highest power. First is parenthesis, then the exponent, then division. Both division and multiplication have the same precedence. Likewise, addition and subtraction also the same precedence. So these are the precedence or the order of precedence for the operators. Here is an example. If this is a generic way of representing it, as I said, parenthesis will have the highest power. So if I put a parenthesis somewhere here, then that means this operation will take place first. Then after that, exponent will be the highest one. Then the division or multiplication. After that, we go on with the addition and subtraction. So the final answer here is 5. You can check. Next is the assignment operators. In the assignment operator, we assign a value from right to the left operand. So if I have a equal to 10, I am assigning the value of 10, which is in the right side, to the right operand, which is a. Likewise for the b also equal to 5. Now plus equal to is representing the adding two operand. No, like if I'll show with the example itself, it's a plus equal to b, that can be rewritten as a equal to a plus b. So you are adding a plus b, and that is equivalent, that is you are making it equivalent to a. So it is print a. So 10 plus 5 equal to 15. Likewise for the subtraction, a equal to a minus b, then you will have it as 5. And the next one is multiplication. So here it is a equal to a into b. You can replace it by this symbol or the operator, which you will get it as final answer as 50. Same way for the division, if you do it as a by a slash equal to b, can be written as a equal to a slash b or a divided by b. Then it is 10 by 5 equal to a, then that is equal to 2. Next is the relational or comparison operator. This shows the less than operator, and this is the greater than operator. This means this, if I use this operator, then this will become true if my left operand is less than the right one. Say for an example, I take these two examples, x equal to 5 and y is equal to 7, and I print x is less than or equal less than y, which means x is less than y, of course, because 5 is less than 7, then it becomes true. Suppose if I put y less than x, then the answer will be false. Likewise, less than or equal to. I am printing x less than or equal to y. Yes, of course, because it is less than anyway, so it is true. Same way for the greater than operator. I put it as x greater than y. No, it is false. Suppose if I put y greater than x, yes, it's true. Same way for the x greater than or equal to y is false. for this example that we took. And next is double equal to, which is equal to. We are trying to check whether the both operands are same or not, or equal or not. So if I put x double equal to y, which means if I'm checking whether my x is equal to y. No, because it's 5 and 7, they are not equal, so it is false. And here it is again, it is the no checking whether it is true or false. If the operators are not equal, then it becomes true. Yes, because it's a not symbol, right? So x not equal to y. Yes, x is not equal to y, so it is true. Next is the logical operator. In logical, it is OR operation, AND operation, not XOR. Likewise, we go. So we know what is OR. Logical OR. Logical OR is if we have two operations, like if we have 2 bits 0 0 0 1, like the answer becomes 1. If even if I have only one operand as high. So if it is 0 0, the answer is 0 0 1, then it is 1 1 0. It's also 1, and for 1 1, it's also 1. So for my OR operation, I should have any one operand should be high or 1, or it should be true. If any one is true, my output will be true. Here I am trying to print the example. See, same way, x equal to 5 and y equal to 7. So x greater than equal to y, no, it's false. Or x less than x is less than or greater than, any one will become true, because in any one it is true, because 5 is less than 7. So obviously any one case is true, or condition is applied, so it is true. Whereas for the AND, if both the operands are high or both the operands are true only, the answer will be true, else it is false. For our example, if we put the same example here, the answer will be false, because for any one case, either this case or this case, it becomes false. If I take x equal to 5 and y equal to 7, obviously one will become false. So both are not true. Obviously my answer will be false. And not is very simple, logical not. Putting it in the reverse way, x is equal to y, it is actually false, because 5 is not equal to 7. So the answer will be for false for here, and putting in not, reversing it is true. If I put x not equal to y, then that becomes true. Then it becomes not, means false here. Whatever I get here, the condition will be changed, reversed. That is logical not. And the next is bitwise AND, bitwise operation. So here we have, bitwise we check for each and every bit. So bitwise AND here, again 10 4, it is 0, and here it is 14, or, and here it is not, so it is 11, because you are checking it one by one. You have to check bitwise, and the answer you can check it mathematically, like I'll here what is 10, it is 0 0 0 1 with all zeros, 10 10, so 0 0 0. And for 4 it is all zeros first, 0 0 0 and 0. 4 is 100, so 0 1 0 0. Yeah, so when we compare bitwise, so this is 0, this is 0, and for AND operation this is also 0, all zeros. So for AND operation, because any one should, if both the operands are only high, then the output will be high. So for AND operation it is 0, that is why we got 0 for the first one. AND, whereas for not OR, it is 0 0 1 0 1, so it becomes 0 1 and 4 4, so it becomes 14. That is why we got 14 here. And for not, we will be changing the a. This is our a, so I'll put it as 1 1 1 0 0 0 0, all becomes 1, so it becomes 1000, and this one becomes 1000 is actually 9, and here it becomes all 1, so it is e, so the equivalent is -11. Okay, so that is what is shown here. And next is XOR. You know what is XOR? Same, XOR is 0 0 0, 0 1 is 1, and 1 0 is 1, 1 1 is 0, which means even if one operand is high, then output will be high. If both are low, both are high, then the output is 0. So which means if any one case is true, then the output is true. If both the operands are false, or both the operands are true, then the output is false. So you can make a try here. That is why we got it this way. And left shift and right shift is we are trying to shift the bits by left and shift the bits by right. That is what we are trying to do here. Here I gave an example of 2. I'm shifting it by 2 values. So that is, at last I'll get the answer by this way. You can make a try. And next is identity operators. Identity is I'm checking whether it is equal to or not. So if true, if I put yes, then like A is C, yes, it is true here because A equal to 10, I am putting C equal to A, so both are equal, so it is true. And it's not as are they equal now? If they are not identical, then it is true, which means A and B are not true. So if I am trying it as A is not equal to B, A is not B, yes, true. If A is not C, then that becomes false. If I put C here instead of B, then that becomes false. Okay, and even if I put B here, then that becomes false because A is not equal to B and A is not B. And if I want to check the value. Next is the membership operator, in and not in. True if the value is found in the sequence. For an example, I have x equal to 24 and y equal to 20. I'm putting a list and creating a list of these values. And I'm going to check, put an if condition, x is not in list. Yeah, of course, x is not in the list. 24 is not there. If x is not in the list, then I have to print it as it's not given in the list. Else I'll print x is present in the given list. Same way, I'm checking for y. If y is in the list, yeah, it's there. So I'll be, for this case, I'll be printing y is given in the list. Else it will be printing y is not given in the list. For our case, x is not present in the list. So it will go to the else condition. So x is present, x is, sorry, if condition, x is not present in the list. So I'll get the answer by that way. And for the y, it is again present in the list. It is in the y condition. So it is this answer. Thank you.